A pod of orcas is creating what scientists call a wave wash, a synchronized surge of water from four bodies weighing several tons, directed straight at an ice floe where a solitary seal rests. The floe tilts. The seal slides. And the hunt ends before the seal can understand what has happened. This is not pure instinct. It is a strategy taught from mother to calf, from one generation to the next. And this is the Pacific, the largest ocean on the planet. But here is the real question. Which of these predators is truly the smartest hunter in the ocean? Stay with me, because the answer might completely surprise you. Please give us a like and subscribe to the channel to give us more motivation to keep creating quality content. Don't forget to leave a comment below telling us what you thought of the video, and let us know where you're watching from so we can chat together. May Mother Nature bless everyone with good health, peace and love for nature. Let's begin. With over 63,700,000 square miles, more than a third of the Earth's surface is covered by a single body of water that plunges to 36,089 feet in the Mariana Trench. 25,000 islands lie scattered across the waters that Ferdinand Magellan once called peaceful, in the year 1520. But beneath that placid surface, 90 of the world's earthquakes rumble along the Ring of Fire. Pacific is simply a name, not its nature. Because beneath these sapphire waters, 170 million cubic miles of water, almost half the total oceanic volume of the planet, cradle a diversity of life that continues to amaze us. The Coral Triangle in the Western Pacific, home to the greatest marine biodiversity on Earth, is proof that this ocean is not only the largest, but also the richest. Welcome, let's explore the most extraordinary stories of the natural world. The most intelligent survives. But intelligence in the ocean is different from anything we have defined. It takes the form of venom, of bioluminescent light, of immortality, and of migrations 100 million years old. In the widest ocean on the planet, what form of intelligence determines survival? The answer begins with a creature to which even the great white shark gives way, the orca. And no predator on the planet possesses more sophisticated tactics. Orcas, despite their formidable name, are in fact the largest members of the dolphin family. And what makes them the most formidable predators in the ocean is not their size, but their intellect. They live in family groups called pods, matriarchal clans led by the oldest female, where knowledge is passed down from grandmother to mother, from mother to calf. This is a matriarchal society, one of the most complex social structures in the ocean. In the Northeast Pacific, researchers have identified three distinct ecotypes of orcas. Residents, which specialize in fish. Transients, which hunt marine mammals. And offshores, which feed on sharks. Three types, three strategies, and each pod possesses its own dialect, a set of calls that no other pod can accurately replicate. In other words, each orca family speaks a different language. When they hunt, their tactics would astound a military strategist. Using a technique called carousel feeding, orcas surround a school of herring, grouping them into a swirling, compact ball. Then, one by one, each orca strikes the ball of fish with its tail, stunning dozens of prey at once before circling back to feed. None eats out of turn. None breaks formation. Their maximum speed is 34 miles per hour. But speed is not their main weapon. It is their coordination that is truly remarkable. Orcas teach their calves to hunt. Mothers have been observed intentionally releasing wounded prey for their calves to practice on, a behavior scientists call cultural transmission. This is not inherited instinct. This is education. Orcas have no natural predators. They sit at the top of the ocean's food chain, not through brute force, but through a collective intelligence perfected over millions of years. Orcas demonstrate one thing: in the ocean, the sharpest mind is a shared mind. And what makes it even more impressive is that orcas are the only marine species in which scientists have recorded cultural diversity among populations. Orcas in Norway hunt herring using carousel feeding. Orcas in Argentina beach themselves to catch sea lions. Orcas in New Zealand specialize in hunting rays. The same species, completely different tactics. Much like human civilizations developing different technologies, yet all remaining human. But the ocean does not follow a single path. Not all intelligence requires a pack. Some predators choose a path of solitude and perfection. Beneath the deep blue surface, a shadow glides in silence. The great white shark, the ocean's most solitary hunter, needs no allies. It does not hunt with cunning. It hunts with perfection. 400 million years of evolution have designed a flawless ambush machine. From the darkness below, where light cannot reach, the great white shark looks up and waits. Patience is its first weapon. Speed is its last. When it attacks, it launches from the depths at over 34 miles per hour, sometimes coming completely out of the water in a powerful lunge that researchers call breaching. Off the coast of South Africa, this leaping behavior has been filmed hundreds of times. Each launch is a precise calculation, the angle of attack, the approach speed, the moment of impact, all executed in less than a second. But its true secret weapon lies in its snout. Hundreds of ampullae of Lorenzini electroreceptors allow the great white shark to detect the faint electric field generated by its prey's heartbeat. Even if the prey hides under the sand, its heart keeps beating, and the great white shark hears every pulse. Its jaws are lined with multiple rows of triangular serrated teeth. Each one is continuously replaced throughout its life. In a single lifetime, a shark can grow and shed more than 20,000 teeth, a machine that nature endlessly maintains. And its role in the ecosystem is irreplaceable. As a population controller, eliminating the weak and sick, the great white shark keeps prey species in their healthiest state. If it were removed from the ocean, the entire food chain would lose its balance. Its conservation status is vulnerable. According to the IUCN, the ocean's most perfect predator is threatened not by a natural rival, but by us. The great white shark does not strategize in a group like the orca. It does not need to. 400 million years have written every tactic into its DNA. Its intelligence is instinct, a form of brilliance that requires no thought, only action. The orca hunts with collective cunning. The great white shark hunts with solitary perfection. But the ocean hides forms of intelligence that are even stranger. And next, we will meet creatures that prove a large brain is not the only requirement for brilliance. The hammerhead shark, its strangely flattened head, which science calls a cephalofold, is not a design flaw. It is a biological radar. Spread across the entire surface of the cephalofold, thousands of ampullae of Lorenzini turn this head into a 360-degree scanning device. The eyes, placed at the ends, grant them superior stereoscopic vision, detecting prey even when they are buried under the sand. Of the 9 species of hammerhead sharks, the great hammerhead is on the brink of extinction, listed as critically endangered by the IUCN. By day, hundreds gather in formation, a sight that few divers forget. By night, they scatter to hunt alone, feeding mainly on rays. The intelligence of the hammerhead shark is sensory, a way of perceiving the world with faculties that humans do not possess. But at the other end of the spectrum, a 39-foot giant glides through the water, attacking nothing at all. The whale shark, the largest fish on the planet, which often reaches 39 feet with a record of 61.7 feet, is a filter feeder. Its mouth opens as wide as a door, but only to suck in plankton, small fish, and fish eggs. No fangs, no venom, no weapons of any kind. At its side, remoras cling with suction discs on their heads, feeding on scraps and finding protection in the immense size of their host. Even the whale shark's passage through the ocean creates a mobile ecosystem. Each whale shark bears a unique pattern of white spots, as individual as a human fingerprint. Scientists use these same patterns to identify individuals. But the whale shark population has declined by more than 50 in the last 75 years. Its status is endangered. According to the IUCN, the ocean's gentlest giant is slowly disappearing, not because it is weak, but because the world around it is changing too fast. The whale shark's intelligence is renunciation, giving up weapons, abandoning violence, and yet enduring for millions of years. But in the deepest darkness, an 8-armed creature waits, and it may surpass them all. 500 million neurons, that is the number of nerve cells in an octopus's body, more than some mammals possess. But what is truly strange is that 2/3 of those neurons are not in its brain. They are in its 8 arms. Each of an octopus's arms acts as a miniature brain, capable of making its own decisions, reacting on its own, even tasting and feeling the environment without waiting for orders from the central brain. If the orca is a collective genius, the octopus is a distributed one, an intelligence without a center, spread throughout its entire body. And its ability to camouflage defies imagination. Millions of pigment cells, the chromatophores, cover its skin, allowing an octopus to change its color, pattern, and even texture in less than a quarter of a second. One moment it looks like a piece of coral, the next it becomes sand, then mud, and then it disappears completely. The mimic octopus takes this art to its zenith. It can imitate the shape, movement, and behavior of over 15 different species, from rays to lionfish, from jellyfish to sea snakes. This is not a simple defensive reflex. It is a performance, a drama of survival that changes with every scene. The octopus is also one of the few known invertebrates that uses tools. In Indonesia, researchers filmed an octopus picking up two halves of a coconut shell, carrying them with it as it moved, and then assembling them to form a shelter when it needed one. An invertebrate that plans for the future. Its blood is blue because it uses copper-based hemocyanin instead of the iron-based hemoglobin found in humans. 3 hearts pump this blue blood. 2 branchial hearts move the blood through the gills, while a systemic heart circulates it to the rest of the body. When threatened, an octopus releases an ink cloud, a dense, dark plume that not only obscures its enemy's vision, but also temporarily numbs their sense of smell. It can slip through any opening larger than its beak, the only hard part of its boneless body. A 19.8-pound octopus can slide through a hole the size of a quarter. An intelligence of transformation, a distributed intelligence, a spineless intelligence, both in the literal and figurative sense. But perhaps the most moving thing about the octopus is not its intelligence. It is its sacrifice. A mother octopus lays her eggs in a dark den and guards them for weeks. One species does so for up to 4.5 years. During all this time, she does not eat. She constantly fans the water to keep the eggs oxygenated. She chases away all intruders. And when the young hatch, the mother is completely exhausted. She dies right next to the new generation she will never see grow. Each young octopus swims into the ocean alone, carrying the legacy of a mother who traded her life for their existence. The intelligence of the octopus does not reside only in its arms or in its chromatophores. It resides in the instinct of sacrifice, the oldest form of intelligence evolution has ever produced. You can trap an octopus in a sealed jar. It will open the lid from the inside. Experiments have shown that octopuses can solve problems, remember solutions, and even recognize individual human faces. A creature that lives no more than 2 years, but in that brief time shows an intelligence that many species living for decades cannot match. The octopus deceives its enemies with shape. But in the depths of the ocean, there is a creature that deceives time itself. And it does so without a single brain cell. No brain, no heart, no blood. 95% of its body is water. And they have existed for over 500 million years, longer than dinosaurs, longer than fish, longer than insects. Jellyfish. Seemingly the simplest creature in the ocean, but one of evolution's greatest successes. In the dark canopy of the deep ocean, some species of jellyfish glow. Bioluminescence, living light, turns them into floating lanterns in the eternal darkness, attracting prey or warning predators. The tentacles of a lion's mane jellyfish can be more than 98 feet long, longer than a blue whale, the largest animal that has ever lived. Each tentacle contains millions of cnidocytes, stinging cells that fire faster than a bullet, without a brain to calculate, without eyes to aim. Yet their success rate in capturing prey is astonishing. Jellyfish do not think. They do not plan. But 500 million years of evolution have written every necessary response into every cell. A design so simple that it is perfect, and so perfect that it has not needed to change in 500 million years. And then there is Turritopsis dohrnii, the species science calls the immortal jellyfish. When injured, stressed, or old, Turritopsis dohrnii does not die. It reverses its life cycle, transforming from an adult back into a larval polyp, and starting its life anew. This process is called transdifferentiation. Adult cells revert to stem cells, then grow back into a completely new body. It is not eternal youth. It is aging, and then returning to youth. A cycle that, in theory, could be repeated endlessly. No brain, no heart, but it has conquered death. If intelligence is measured by the ability to endure, then the jellyfish, the simplest creature in our history, possesses the ultimate form of wisdom, one that evolution took 500 million years to create. Immortality requires no brain, only enough time for nature to find the answer. That is the most profound lesson the Pacific Ocean offers us. Intelligence has a million forms, and sometimes the simplest is the most powerful. So tell me, what form of intelligence do you find most impressive? The orca's strategy, the octopus's transformation, or the jellyfish's immortality? Let me know in the comments below. I read every single one. From the immortal, we now move to creatures that choose the opposite path, living short but deadly lives. Because in the Pacific Ocean, venom is also a form of intelligence. The banded sea kite. Its venom is more potent than that of most terrestrial cobras, enough to kill a human adult in a matter of hours. But here lies a paradox. The banded sea kite almost never bites. Its temperament is so placid that many divers swim right beside it without being threatened. Its venom is an ultimate weapon, but one that is deployed only when absolutely necessary. At night, the sea kite slithers through coral crevices hunting small fish with a surgically precise bite. Its lungs are so efficient that they allow it to dive for long periods before returning to the surface to breathe, or to land, to rest, digest, and shed its skin. The banded sea kite is a bridge between two worlds, the land and the ocean, and its venom is its passport to both. Intelligence here is chemical warfare, possessing devastating power but knowing when not to use it. But not all venomous creatures are so restrained. The lionfish, with 18 venomous spines distributed across its 13 dorsal, 2 pelvic, and 3 anal fins, has no need for restraint, because in the Caribbean waters it invaded in 1985, there are no natural predators to keep it in check. The lionfish spreads its wide pectoral fins like a fan, corners small fish, and swallows them whole. A female can lay between 12,000 and 15,000 eggs every 4 days. It consumes over 50 species of native fish. A perfect invader, captivating, astonishingly fecund, and unstoppable. The lionfish intelligence is one of conquest, but also a warning. When a form of intelligence invades beyond its natural limits, the ecosystem pays the price. Venom, immortality, camouflage, these are the intelligences of the individual. The ocean has shown us how individual organisms can possess strategies beyond imagination. But the ocean hides another form of intelligence. The intelligence of silence, of those who become nothing. The leafy sea dragon. Looking at it, you would think it is a piece of seaweed adrift in current. And that is precisely what it wants you to think. The leaf-like appendages that cover its body are not for swimming, but for disappearing. The leafy sea dragon is a master of camouflage in the waters of southern Australia, where it blends into the kelp forests with such perfection that it becomes invisible. It has no teeth nor a stomach. Its food, mainly mysid shrimp, is sucked through its tube-like snout and passes directly through its short digestive tract. And in this species, it is the male who carries the eggs, up to 250 of them attached to the underside of his tail for 8 weeks, until tiny miniature versions of himself hatch and swim into the ocean. Its conservation status was recently upgraded from near threatened to endangered by the IUCN. A dragon with no scales, no fangs, no weapons, just the art of remaining invisible, is slowly disappearing. The leafy sea dragon's intelligence is invisibility, a form of brilliance that does not show off or attack, but simply disappears. Not far from where the leafy sea dragon hides, a close relative drifts, but does so vertically. The seahorse. The only fish on the planet that swims in an upright position, using its prehensile tail to cling to corals or sea grass beds to avoid being swept away. They change color to blend in with their surroundings. They have no stomach. Food passes through their bodies so quickly that they must eat almost constantly. The courtship dance of the seahorse can last for days. The pair entwines their tails, changes color in sync, and moves as one through the seagrass beds. Unlike the leafy sea dragon, it is the male who becomes pregnant. He receives the female's eggs in a brood pouch on his abdomen, then nourishes them until hundreds of young are ready to be born. Of the approximately 46 known species of seahorses, many are threatened by habitat loss and the trade for traditional medicine. Every year, tens of millions of seahorses are harvested, creatures whose only strength is their patience. The seahorse's intelligence is patience, and a role reversal that nature has conservatively maintained for hundreds of millions of years. The leafy sea dragon and the seahorse, an intelligence of silence. Creatures that need no roar, no venom, no speed. They only need to disappear or wait. And the ocean lets them be. But venom, camouflage, immortality, transformation, these are all the intelligences of the individual. Each organism on its own has found a way to survive in the widest ocean on the planet. The question now is, what happens when millions of creatures without individual intelligence merge into one? When none is strong enough to survive alone, but a million together becomes something that no predator can completely destroy. Collective intelligence, the most powerful and paradoxical intelligence of the ocean, lies ahead. And here is a number that will stop you in your tracks. It begins with the smallest fish in our story. A single sardine, less than 8 inches long, less than half a pound.
no fangs, no venom, no armor.
Alone, it is among the most vulnerable creatures in the ocean. But 1 million sardines, that is a force no predator can ignore. Sardines move in shoals, schools that can number in the billions, stretching for miles through the water. There is no leader, no central brain in command, no fish gives orders. Then how do a billion fish move as a single entity? The answer lies in the lateral line, a sensory organ running along both sides of the body, allowing each sardine to feel the movement and water pressure of its neighbors. Each fish reacts only to its 3 closest companions. But when a billion fish follow that simple rule, the result is a massive superorganism moving with flawless coordination. When attacked, the school forms a bait ball, a dense swirling sphere where each fish constantly changes position, making it impossible for a predator to target a single individual. The sardine run off the coast of South Africa is one of the greatest biological events on the planet. Billions of sardines migrate along the coast, forming a silver ribbon tens of miles long, and every predator in the ocean knows it. The sardine is the central link in the marine food chain. Without sardines, whales have no food. Dolphins have no prey. Sharks have no energy source. The entire oceanic pyramid would collapse. The ocean poses a question between individual and collective intelligence. What is the ultimate solution? Sardines demonstrate the power of numbers. But one species goes further. They do not just move together. They know each other. And they know themselves. Dolphins. Of the approximately 40 species of oceanic dolphins, the bottlenose dolphin is perhaps the most studied, and the more we study them, the more they amaze us. Each dolphin possesses a signature whistle, a unique sound developed in infancy. This is not a random call. It is a name. When one dolphin calls another by its name, the one called will respond. When a mother is separated from her pod, she emits her name so her calf can find her. In the entire animal kingdom, aside from humans, almost no other species is known to have a system of individual names. Place a mirror in front of a dolphin and it will turn, inspect marks on its body, and even open its mouth to look inside. This is the mirror self-recognition test, a benchmark of self-awareness that only a few species pass: humans, great apes, corvids, elephants, and dolphins. They know who they are. A dolphin's echolocation system allows it to see with sound, emitting ultrasonic clicks and analyzing the echoes to determine the location, size, speed, and even the internal structure of an object. A dolphin can distinguish between 2 metal balls that differ by only a few tenths of an inch, in complete darkness. In Shark Bay, Australia, a group of female dolphins has developed the habit of using sponges on their snouts while foraging on the sandy bottom, protecting their beaks from being scraped by corals and rocks. This behavior has been passed down from mother to daughter for generations. Tool use, cultural transmission, 2 traits we once thought belonged only to humans. Dolphin mothers nurse their calves and stay with them for years, teaching them to hunt, to communicate, and the social rules of the pod. They play not just for practice, but seemingly out of pure joy. They surf waves, toss seaweed, and chase each other through kelp forests. They cooperate in hunting, share food, and protect the injured members of their pod. When a dolphin weakens, the pod will lift it to the surface to breathe. Their sustained speed is 20 miles per hour. But speed is not the most remarkable thing about dolphins. The most remarkable thing is this: dolphins are not just intelligent, they are aware of their intelligence. They are a bridge between the instinctive wisdom of the ocean and the self-awareness that we, as humans, once believed was our exclusive privilege. The intelligence of the dolphin is emotion and self-awareness, the form of intelligence closest to our own that the ocean has ever produced. But the story is not over, because the oldest intelligence, one that has endured for over 100 million years, does not belong to the strongest, the most intelligent, or the fastest. It belongs to the sea turtle. 7 species of sea turtles, over 100 million years of evolution. They swam in the oceans when dinosaurs still walk the earth. And they continue to swim long after the dinosaurs have vanished. The leatherback turtle, the largest sea turtle, can grow to more than 5.9 feet long and weigh up to 1,984 pounds. It dives deeper than any other reptile, through freezing waters that other turtles cannot withstand. They migrate thousands of miles each year, from the tropical beaches where they lay their eggs to the cold waters of the North Atlantic where they hunt jellyfish. A pilgrimage with no map, no compass, just an instinct that is over 100 million years old. Its conservation status is critically endangered. But the most extraordinary thing about the sea turtle is not its size or its endurance. It is its memory. A female sea turtle, after decades at sea, returns to the same beach where she was born to lay her own eggs. Natal homing, the instinct to return to one's birthplace, is a navigation system that science has not yet fully deciphered. At night, under the moonlight, the mother turtle crawls onto the sand, digs a nest, and lays hundreds of eggs. The moonlight and the horizon guide her, and they also guide her hatchlings when they emerge and head for the sea. But only 1 in 1,000 hatchlings will survive to adulthood. From the moment they leave their sandy nest, each young turtle faces a marathon of life and death. Seabirds dive from above. Ghost crabs wait in the sand. And even if they reach the water, larger fish are waiting. It is less than 151 feet, but it is the most dangerous journey of their lives. The green turtle, endangered. The hawksbill turtle, critically endangered. 6 of the 7 species of sea turtles are threatened by plastic pollution, the loss of nesting habitats, and bycatch. The intelligence of the sea turtle is memory, a migratory instinct coded for 100 million years. Not the memory of a brain, but the memory of a lineage, carried in the DNA from one generation to the next. If this journey through the ocean's greatest minds opened your eyes today, hit that subscribe button and turn on notifications, because the next story from the deep might be the one that changes how you see the entire natural world. And listen closely, because after everything you have just heard, you will realize that the ocean has been listening to you too.